Sorry about that. Please continue.
Yes, and so I asked to leave. I didn't have any material. I wasn't. They didn't tell me that I should present some material, but I want to take this graphic that Mr. Rogers presented because it applies. It seems like this is more for process control, and in my case, I'm in the factory automation type of where we deal with all of the robotics. We deal with machineries that are in factories, whether if it's an assembly machine or whether if it's a robot moving cars or moving small components for a medical device or any type of automation equipment. We create those systems. We provide those systems to the manufacturers of the equipment. I am an electrical engineer. I graduated in 1990, and I graduated from Mexico. And I have an associate degree or a technical degree in mechanics, but I have an engineering degree in electronics. I started in the mechanical field, and I realized that mechanic was very touchy-feely, and I switched over to electrical because it attracted me more. But in my professional life, I ended up using both. I work a lot with servo motors and servo drives. Mr. Cooper is it Mr. Cooper, right?
Yes, it's Mr.
Yes,
Tommy.
okay. Yes, I was talking about servos and how he applied servos. We use servos in my field more for position control, for gantry systems, and for assisting the robots, seventh axis on the robot, or adding additional axes on a 6-axis arm or SCARA type robots. So we provide all of those control systems. Before I joined this meeting, I was talking to one of the teams in the Omron Automation Center, or the lab that it's in the University of Houston. And I was providing guidance to the students on the servos and how they, but everything that you see applies in different areas of the industry, not just in process control, but also in robotics. And Mr. Cooper also applied some of these in the devices that they use. We as a manufacturer of components, we provide all of the components that are associated in a control panel that is going to go into an automation system. So an engineer like me would provide assistance to a company like Cooper Engineering when they needed some servo system or some robotic system to do a particular operation to assemble their devices. We would provide those devices. We would provide the engineering support to help them come up to speed, reduce the learning curve. And in my field and in my experience, we didn't get to the level of board level type design. It was more procuring devices that are specifically made and then doing all the integration of them. Taking different brands of different devices, whether if it's a PLC and an HMI or a user interface and a robot from a different brand. And that was my background since I graduated from college and started working in Mexico and then eventually in the United States. It's always been integrating devices that are like PLCs, like robots, like servos from different brands and things like that. And nowadays, in order to get some of these systems built and designed, they, companies require that to build and prototype systems quickly. So the quicker you design a system and bring it to market, everybody wants that fast and quick to try to get their products done, and probably Cooper Engineering hears that quite often. So we assist. That is kind of what we do, and that's been my background. I built machinery, designed the control system, and then did the programming for the PLC, for the user interface, for the interfaces with the production systems, training personnel, whether if it's operators or engineering people or maintenance people, and helping customers keep their equipment up and running. But there's a wide variety of functions, and nowadays employers are looking for engineers that have very hands-on type of expertise, and not afraid to tackle projects like this, and the engineering background gives you all of those, I'm gonna call them weapons, to be able to go into the battlefield, so this is a very exciting time to be in engineering and controls, in robotics, in automation, cybersecurity. Everything is evolving so fast, and it's this is a very exciting time, I feel, where things are changing quickly, and our lives are never gonna be tired mentally. We always, as engineers, are always going to be utilizing our engineering background to solve problems, and like Mr. Cooper explained about how the designs that he go to help others, that are. And so that's what engineering is all about, and that's what our controls engineering are going to help, in circumstances like in the case of in the Army and things like that. So I would love to hear questions, feedback, or and maybe we can provide some additional guidance.
Do you guys have any questions or comments or anything you'd like to add? Check the chat.
Don't be shy. This is the right time to ask questions. This is the perfect time. When you're in school, this is the best time to ask questions, and there is no such thing as a bad question,
So I know we're talking about a lot of controls, a lot of signals, a lot of communications. When you're looking, or if you were to look for a new hire into one of these positions, what types of skills would you like them to have? Both like soft skills and both hard skills. What would you like them to know coming in?
So, well, I was was it that for me or for Mr. Cooper?
That was for both of you.
So I'll talk about, because I was a supervisor in a previous role. I was an automation manager in a different company, and I was hiring engineers, and in the area that I was in, which is factory automation, I would look for expertise and experience in control system design and programming, control system programming softwares, whether if it's the brand that I was looking for or different brands, you know, and understand their backgrounds and capabilities. You probably see a lot of, I don't know, LabVIEW in some of those that are, you know, and that's a different area. I was more into industrial, and so we would look for PLC background programming and designing and control systems, and seeing what kind of projects they develop through, especially for new hires, what kind of projects that develop and how they would fall into, you know, into what the position that I was looking for. So, you know, those are the, you know, and I'm looking at this list that you have on your presentation, and, you know, it will give me a good a baseline to understand, you know, the background of the person who was looking for a position in our company, and, you know, and how willing are they to learn new expertise or gaining expertise, trying things. It's a very important.
Got it. And would you say experience with FPGAs are also like an added bonus to someone looking into a position with this? Hello?
Probably for he's muted, Mr. Cooper. You're muted.
So
There you go.
yeah, so that's a little more hardware specific. I mean, you use those in certain circumstances, and it's a little more specialized. What I'd be looking for is more a background, and that's a little. I need less kind of say focused effort. I need someone who can do hardware design, software design, and do both controls, signal processing, and the analog front end. You'd be surprised. Every project we work with requires all of those skills. So earlier in my career, I was actually hired. One of my first jobs in industry, I was hired because I'd done a microcontroller project, and it was pretty early on. It was in the mid 70s. And so I was hired in as their microcontroller expert because no one else had done one. And so I had to get, you know, to work through that and design a defibrillator monitor that used a micro. It was the first microcontroller-based defibrillator monitor for a medical product. But as it is, there's skill sets that have to do with experience in working with circuitry and designing systems and designing PC boards. So mine's a little more down at a kind of a finer level than for Ricardo, but I need it down at the level where they, you know, they're picking resistors and capacitors. I mean, you're down at that level. So I need that, but I need somebody that can write software, write firmware. We use everything from LabVIEW to microcontroller software to Python to you know, what I have in terms of who's in the office. We have one of our engineers that's LabVIEW certified, and he a certified developer. He's also writes microcontroller software, and he also does, you know, he designs the GUI on the screens that you see that you operate the screens off. A lot of our stuff are touch screen, so he's doing that. But he's also designing hardware. He's updating a schematic for one of our products right now and getting that done. Now, we usually get our PC board stuff done outside, but you can see that it has that. And there's elements of design that are that cover everything from all the power sources, running things off batteries or off AC line, running things off of, designing. We typically have probably 5 or 6 different voltage regulators in every product we design. Every PC board has that many. We need all these voltage rails. We need a separate one for digital from analog. Sometimes we're coming in with a lithium cell and it's at 3.7 volts and I need a 12 volts to run this particular part. I have to step it up. Sometimes I'm coming in with a little higher voltage and I have to take them down. So there's a lot of those kind of things, and just learning how to integrate all of those things together and make it work. Now we'll show you something. Can you allow me to share screen?
Absolutely. Stop our share.
Here we go. Do you find it? Just go under share screen and you should be able to find it where it says, allow multiple users.
Co-host? Yeah, because that I do not see. Go down to people of this. Go here.
So do you have kind of a toolbar along the bottom that has participants chat and then share screen?
And see that, hit that.
Right. Oh, there we go.
Make co-host. There you go.
Okay.
Now you can share.
All right. You should be able to share now.
All right.
All right. Thank you. I appreciate it. No problem. Yeah.
Right. So I said we'd worked on a dialysis system. So we did several versions of this. This is the device that actually got released as a medical product, and this was done by a very large medical company over in Europe, and we did this work for them. We were the project lead on it up until we eventually transferred it over to them. So this is a remarkably complex device. And so how do you deal with that? And you were hearing about safety systems on a device like that. So how do you deal with the power supplies on it? So this is just dealing with the power supply. So we have an AC power supply coming in. Here's our battery. It's a 24-volt battery, and I have a charger, so I've got to be able to charge that. And I've got to run all these components off of these different power supplies. There's a 5-volt supply, 24 volts. And this system, so here's just the connection of all the power supplies. I have a 12-volt step down. I have a 5.8 volt step down converter. I have a 5.8 volt, a second one. And then why do I have so many? Well, part of it is that this system, you heard about safety systems. So I had to have a primary system, and then I had to have a separate supervisory system. And I had to run I had to have separate power supplies for each one. So this has all those features in it. So what did that look like when you did an overall hardware diagram? Let's see if I can make this a tiny bit smaller. So it looked like something like this. It had a single board computer that ran the whole system, but it also had a secondary microcontroller that supervised critical safety critical areas. So, and this has, this, if you look at all the buses over here, there's all these USB buses and Ethernet bus, SATA power, USB, RS-232, and it used all of these, and we eventually had I2C running all over the place, because we had to connect things. So one of the more interesting ones was what it looks like when you look at a safety diagram for it. So this is, anything in red is safety related. So anything we told it to do, anything that could take a command that we had to tell it to do something, we had to verify that that happened. So everything had a verification on it, because when you're pulling blood out of the body and this thing runs unattended, So if you had an attended device, that would be different. So this thing has to be safe and run. When I say dialysis machine, you might think of something where people go to 3 times a week and get dialysis. This is not that type of dialysis machine. This is used in ICUs, and it's mainly used on people who have congestive heart failure. So they come in, they're in cardiac instability, they have a 20 to 40 liters of fluid overload in their body that they've just retained. And they're going into multiple organ failure, their kidneys are failing. So this machine is connected to them, it pulls their blood out, it performs the dialysis type things, it removes metabolic waste, it does acid-base balance, it does electrolyte balance, and it does all that and removes all that fluid. And you only have maybe 6 liters of blood in your body. So this thing's processing all that. And what it slowly does is removes all that excess fluid in your body. So this thing runs like that, and it runs basically unattended. And so it has this main control system, and these are all those components that it's running out here and talking to. So whether it's, because it's also providing anticoagulant to the blood. So this was a very complex system. And you talk about all the signals and controls and so forth. So this had at least 2 PID loops running in it. It has 4 pumps, actually 5. And one of them's a blood pump that pulls blood out of the body and sends it back after it's been filtered, let's say. And then it has pumps that put fluid in and take fluid out of the blood through a hemofilter. And then it has another pump or 2 that actually deliver the anticoagulant to it. And then it has a 300-watt warmer that warms the fluid. That warmer has a PID loop on it that controls the temperature. But everything you do when you do the temperature control, even, you have to not only measure it once, you have to measure it twice, because you have to have a redundant system that supervises that your temperature is not getting out of whack, because if you deliver fluid that's too hot to the blood, it'll damage the blood or denature some of the proteins in it. So this is what you get into if you stick around long enough. You get to work on very complex systems like this. But look at all the safety features in here. And those all talk back to this protective microcontroller. So everything is redundant. So this is the kind of thing you can get into when you're doing these kinds of systems that they get very complex. And here's kind of a neat diagram. So this shows you all those pumps and the diagram showing you how all the disposable portion of it works. So here's the fluid warmer bag. So here's where the rubber meets the road. Blood is pulled from the body and goes to this blood pump, and then goes through this hemofilter and comes back out, and it goes back to the body. So that's the main loop. These others are doing processes. So if you see these letters up here, this is continuous veno-venous hemodiafiltration. That's what that stands for. And so this process that they're looking at is post-dilution. So they dilute the blood, and then they suck that fluid out of the blood, and it pulls some of the waste matter and things that they need to remove. Like this is doing the kidney's job. It has 3 bags, 3 load cells that measure these bags. So this is the dialysate solution that's used in the dialysis part of that. This is replacement fluid that's used in filtration. And this is where the waste fluid goes in those effluent bags. These load cells have to be 0.05% accurate. So when you talk about all this, this is the kinds of things that you get into. This is probably the most complex system that I've worked on and been responsible for. We have others that are pretty complex, but this is the most complex one that I've worked on. And it's on the market today. It's used worldwide and internationally. I kind of follow enough things where I get reports on it where they're using it around the world. So this is the kind of thing as an engineer you can get into. You just have to kind of, you don't do this in the first year you get out of school.
Yeah,
But you can't, but this is what this is sort of the challenge that you work up to, and being a member of this team, you start learning and becoming an expert on this. I will show you, go back to the first picture here. There's something kind of interesting about it, where I showed you where they were introducing it. So this fellow here was the marketing guy, but you see these two guys back here in the background. Now, the people we worked with and interfaced with were in Budapest, Hungary. So the one on the left is now the director of the engineering group there in Hungary. And the one on the right was a young engineer that's been 6 months in my office. He's also Hungarian. And so this is part of the group that I work with in doing this. And so it's kind of it's a neat thing to see this out there and see that people are, it actually not only does, there's 4 of those processes that they use for the patients I talked about, the ones that are with congestive heart failure. It actually does 11 procedures. It does a lot of something called hemoperfusion. It does plasma exchange. It does a lot of other ones. And all those were programmed into this. And we worked on all that, setting all that up. So like I say, if you stick around and keep enhancing your skills and learning, you get to work on interesting things.
very interesting. And
We have I'm sorry, continue.
no, I was going to say, what was the timeline that it took to develop a system like that, Mr. Cooper?
Well, I have one that looks kind of like this in my office. So we had designed a system that is not this one. We designed another system that's a precursor to this for a startup company out in California. And we took it all the way through to FDA approval and CE mark, so we could market it in Europe. The angel investor decided he didn't want to invest another $10 million and take it to market, and told us, go find a partner. This was our partner we found. They wanted it completely redesigned and redone. So I started working with them in the first meeting I had with them was in May, and the contracts were signed in July. Second big meeting was out in California, was in August. We presented all the concepts, and then there was kind of some big changes that happened during the fall because of the way we were doing the coagulant delivery design. I still was arguing with them about specifications over the spring. I had not put one pencil to paper designing a circuit for this until May. We delivered the first one that looks a lot like this in October.
Yeah.
So we had a mechanical design group that we hired to work and do that part of it, but all that circuitry in there and all these boards that hold all this, we did all that work in a remarkably fast time frame. It didn't get it to market that quick. This requires a lot of clinical testing and so forth, and safety testing. So it took it another probably 2 to 3 years to finally get to market. But you have to realize that once I turned it over to them, working with the Germans is challenging. Let's just put it that way. So they go to great lengths to do things, but in actuality, a lot of the design is still from the original things that we sent them. They didn't change it that much. This has some evolutionary changes, but not much.
So we had a question from our person. Go ahead.
Yeah, so how would one get into the medical device industry as an electrical engineer?
Okay, so the question that was asked was, how would one get into medical device industry as a double E?
Well, I did it because I wanted to. It was what I wanted to work on. I wanted to work on medical devices. And I had a friend who was a bit ahead of me in college, and he was working over at the medical center. So that was part of what I looked for. So there's things you can do, or if you want to do that, it is it's quite a learning experience to learn, about these different treatment modalities and techniques for doing things that you have to have a working knowledge of to do this. Is the question really, how do you get that? Well, part of it is, even as a student, there are places in Houston. I mean, we have, and this is not a Texan bragging about Texas or a Houston bragging about Houston. We have the most remarkable and advanced medical center in the whole world. So there's opportunities over there. What you do is go over and search on things like TMCX, Texas Medical Center, and they have a place over there where they are doing incubating startup companies, and it's over off Holcomb Boulevard. And there's all sorts of meetings over there you can go to and start finding out about different companies, even in the Houston area, that are doing things and meeting those people. I mean, you have to search them out. There are companies in the Houston area. There's one not far from the college, from University of Houston. It's called Millar Instruments, or Millar, and they make medical devices. I worked there for a little while, long ago. So they're around you. You just don't realize it. You have to do some searching and so forth if you want to find a company to work for. But they're out there. Millar Instruments. Millar is a good one, and there's others.
Thank you. Does anyone else have any questions, any comments they'd like to add? Okay, so thank you so much, Mr. Cooper. Thank you so much, Mr. Gomez. We're going to proceed with our student representative. If you'd like, you could stick around, but if you're busy, we appreciate your time and wish you the best.
You bet. Well, thanks, guys.
Thank you. Thank you for the invitation.
No problem. Thank you guys for coming. Well, virtually.
You bet.
Okay. Yep. Do you have anything you want to present, or?
Not really, not unless we want to.
Okay, cool.
We did have a lab that we did in USP. It's not really too exciting.
Okay, it's up to you. You can talk about whatever you want. Let's see. I just have some reference things in case you want them.
Okay, yeah.
Let's see. It's just like this stuff. Let's see those columns. See.
Okay, yeah, I was reading this down earlier.
Okay. Oh, yeah. All right.
Oh, yeah.
It's up to you.
Yeah, that's actually a good one. I was looking through that one before I showed up.
Nice.
Cool.
Right, so please introduce yourself.
Yes, I guess I just should stand in front of the camera. How many people do we have online? Or a couple?
No.
No.
It's really just
Okay.
looking in person right now.
In person, cool.
We are.
Okay, cool. Well, my name is Chris Staples. I've been at UH for too long now. And now a little bit about me. I'm not kind of the typical student you might hear of. I didn't come straight out of high school and go to college. Actually, if you would have asked me in high school, are you going to go to college? I probably said no, right? I just ended up working, and then, I didn't know what I wanted to do in life. So I just kind of started, going wherever the wind blows, right? And let's see. But now, kind of what got me into engineering was I got a job doing manufacturing, and in Houston, there's quite a bit of manufacturing, and specifically we were making devices for cleaning out chemical reactors. And actually, I've been to one of the Enterprise plants. Forgot the one, but it was the one where we were cleaning the desiccant out of the propane dryers. And that kind of got me into engineering, was learning about manufacturing. And kind of at home, I started, getting online and doing tinkering things. And I learned, I kind of realized, hey, this is what I like to do. This is fun. I like tinkering with things. I like building things. I like learning about stuff. And specifically what got me into electrical engineering was playing with microcontrollers, right? You get online and you start learning, I want to learn how to program. That sounds fun. And I started programming microcontrollers, and then kind of led me down a rabbit trail of learning about circuits. And I realized, hey, I don't know what I'm doing. And that's actually how I got here into electrical engineering colleges, because that's what I like to do. I like to play around with things and tinker with things, and I wanted to learn how to do that better, how to tinker better, I guess. Right. 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 So I guess now are you three? Are you guys interested in controls? Is that why you're here? Kind of, sort of. Are you kind of feeling it out? Are you freshmen, sophomore? So you're right at that point where you need to make a choice of, okay, here's what I need to do, and that's kind of going to impact what you do the rest of your life, right? And you know, if you are interested in signals, I mean, have you guys looked into all the different fields, or kind of really just interested in signals right now, right? Okay, and a little bit about it. You know, I was asked to talk about my experience here. So kind of what you're going to be dealing with in signals is, you know, signals, communications, and controls. They kind of break it down. They group all three of those things into one thing here at UH, right? And you know, kind of some of the classes you'll see in signals is going to be digital signal processing. And what you're going to do there is you're going to learn about, you know, how to sample signals, how to sample them at the correct rate so that you don't end up with aliased or misrepresented signals, because that's never good for trying to control something. And you learn how to look at signals in different ways, right? So, you know, if you were to look at this, can you see the cursor there?
Yeah.
Yeah. Okay. So if you're going to look at something like this on the screen, you know, there's different ways to think about that, right? You can think of it, okay, what are the frequency components that go into this signal, right? And how do I filter that out to extract actually what I need out of it, right? And you can see that, you know, maybe some of these things might be filtered out on these lower signals, right? You get this mess of a signal up top, and now these three on the bottom, you've extracted out something that you can actually use to either control a device or, you know, take readings from a device, right? There's digital video processing, which, you know, I personally, I wanted to take that class. I didn't have an opportunity to, but it sounded interesting. Another class that you might do with signals would be, this says electives that go with it are yeah, control electives, right? Let's see, and there's another one I read that was talking about electronics. But we'll come back to that. Another thing is communications. So I actually got to take an introduction to telecommunications last semester. And if you're interested in things like sending signals over airwaves, right, that might be what you're looking into in that class, right? So you're talking about, you know, how these electromagnetic waves propagate, how they reflect, how they scatter, you know, and then also how to receive those. And then when we did the labs for those classes, it was pretty cool because we actually, you know, we started with some basic things like AM and FM modulation, you know, which is kind of a lot of what you use in the radio nowadays, right? You know, just car radio, you got AM radio, FM radio. But we did stuff like actually how to encode digital signals into these communications so that you can receive them digitally, or how to monitor to know that you're actually receiving clean signals. So that was a very challenging and actually very interesting class, right? You might run into things of principles of internet working, and that's probably going to be very important if you're dealing a lot with PLCs. You know, every single PLC I've ever used has been on the internet. You know, that it's connected to some type of network, and you're sending signals over that to something else and receiving signals. You know, and in fact, a lot of the with the PLCs I've worked with, a lot of the IO units for those, you're actually getting those readings from a network. They're not actually physically connected to your device. So you have to know how to set those up and how to correctly, you know, send and receive signals and the protocols used for those. Let's see, what are we going to talk about? Communications. Yeah, so I guess that would be communications things on there. So the controls classes that UH offers are automatic control systems and state space control systems. So when you're doing automatic control systems, that's going to be things like, you know, we heard some of the engineers talk about PID loops, right? So what is a PID loop? It's something that allows you to have a set point, and your controller will, send a signal to a device, whether it's a pump or a heater, to send the correct signals to that so that you can keep it at a constant rate. You also might use, control loops for things like robots, right? You tell your robot to go to this position here. How do you make sure it goes to that position and doesn't overshoot or oscillate? Other things you talk about in that class would be system stability, right? How do you keep the system stable so that any input or outside influence doesn't cause it to, become unstable and, either start oscillating or you lose control of your device, right? So a bad example would be that Boeing plane that you guys, a couple of years ago, we heard crashed, right? Because it had, sensors that kept the plane stable and it had a sensor malfunction.
And the plan we use,
Right. Yeah, stability analysis. That's a whole thing in itself, right? And state space controls, that class was actually very cool because that's in automatic control systems, you deal with things like systems that have single inputs and single outputs. But now what happens when you have a system that has multiple inputs and multiple outputs? How do you keep that stable, right? And state space controls is a class where you learn about that. You're kind of taking that automatic controls and taking it to the next level, right? And the project we did for that was actually very cool. It was a programming project, but we had to design a flight controller, for an airplane, right? An airplane that has a roll, pitch, yaw, and has positions. And we had to do a stability analysis on a flight controller to choose how to make that system stable. Let's see, controls. So if you're interested in things like that, then controls might be the way you want to go, right? And so whether it's maybe audio signal processing or controlling robots or controlling pumps and motors in a plant, those are kind of things you might that UH has to offer to help you develop those skills so that you can go out and actually apply them, right? So kind of if you're teeter-tottering on the edge of what you want to do, I would say choose the thing that you're most interested and passionate about, right? Because you're the one that has to spend the rest of your life dealing with this, right? And I've really enjoyed going to school, and there's not one time I regret going to school and taking the opportunity to learn. You'll never say, man, I wish I didn't learn something new, right? I've never said that in my life. And in fact, by doing this, you're going to develop the skills and hopefully you choose a field that you're passionate about so that you can continue developing those skills, just like we saw Mr. Cooper talk about those kind of very in-depth processes that he was doing with the the controls on the dialysis machine. It probably takes years and years of experience to be able to design something like that. So I've really enjoyed my time here. This is my last semester here if I don't decide to come back and do a master's. But this is my I'm graduating this semester, and I've really enjoyed a lot of what the school had to offer, especially in controls and what I've learned here. So you guys have any questions? Or
Someone raise your hand.
Yeah, well, you're in those classes, you're not going to learn how to actually control the robots. Like actually right now I'm taking an elective called Robot Operating Systems, ROS, which is
5397.
There you go. Yeah, 5397. That's not exactly my wheelhouse, but it's very interesting to learn about topics like that. Kind of theories on how to develop software for controlling robots. But I mean, if you're looking at things like that, I mean, yes, this controls might be the way to go. Like some of my electives I took, and I took microprocessors and embedded systems where, you know, it's kind of in embedded systems, we designed a robot car and we had to program like PID controls into the car to make it follow a path, right? So, and you know, play around with tuning that, tuning the PID controller we programmed. So, yeah, I mean, if those are kind of things you're interested in there, you can, I think let's scroll down a little bit. Yeah, so when you select your concentration, you're not just limited to the things here. You can actually take electronic, like you can take like more electives that you're interested in. But yeah, signals might be a very good choice to get you going in the right path there, and then choose electives like, for example, microprocessors or embedded systems that might say, okay, I want to design, you know, like microprocessors to control, you know, prosthetics and things like that. That would definitely set you up for learning about that better. Right. Yeah. Advanced digital design. Right. Yeah. And as well as advanced digital design, I'm actually taking a analog electronics course right now. Right. So that would be very good to think about. You know, if I need to actually do analog processing to these signals before they reach my microcontroller, that's actually a good place to learn about that as well, because not every sensor you buy has a standard output. You know,
One signal processing, that's gonna be 30.
right.
One of those.
Yeah, it's 3366, the top one on,
DSP, digital signal processing.
yeah, it's probably.
That's gonna be diesel.
Yeah, this one right here, intro to DSP, that one. Yes, and intro to DSP, that's actually a
Required course.
that's a required course. And actually, I do have my lab here if you're interested in seeing that, what we did for there. Do you guys have time or want to see that?
Yes, oh, there.
Okay.
Yeah, just to,
Base control is to take automated first.
Oh, yeah.
Oh,
and also I think automation control systems is a prerequisite for
Space.
space, yeah.
Yeah.
Yeah, and just to remind everyone, the first three in blue here,
Mhm.
those are required for the concentration, and then you can pick 4 of the white within the box as your
Oh, yeah.
concentration electives, and then you can choose between 2 and 3 other ECE courses. It could be any other ECE courses. You know, just some FYI.
Right. So, I mean, these 3, yeah, well, just like Anthony said, these 3 you have to take, choose 4 of these down here. And then on top of that, you can do things that are in different, you know, different fields, right? So, let's see, computer embedded. Yeah, because like right now, I'm taking this elective right now, analog electronics. That's not part of the signals class, but I was interested in it. And I thought it might be useful, and so I'm taking it. Right?
Same thing for that antenna engineering class. You had an exam course today.
Oh yeah, and yes, I'm an antenna engineer right now.
Oh.
Yep. Yeah, and that one's actually part of the signals. But yeah, you can take classes that aren't part of the, you do have extra electives that you could take that are outside of the signals, if you're interested and think that's, where you want to end up. So you're not just limited to these right here. Yeah, let me see if I can pull up that lab. So the DSP was actually interesting. This was my one of the labs we did for DSP, digital signal processing. We don't have a. So we have a PDF on here.
You could just like drag out to Google Chrome.
Oh, let's see if it opens up here. All right, yeah, so this was so kind of a little background about the lab. What we did is we were cancel the. Yep. So for this lab, we were actually analyzing signals that we recorded, right? So we would record different people saying, different different phrases or different like consonant sounds and stuff like that, and then we would run a frequency analysis on that. And we're supposed to use what we learned in class to do the analysis on them, and we did it all through MATLAB. But on here, you can see these are spectrograms, which just, show here's each little, word. And this is the same thing that has been ran through different filters. You can see how the filters affected it. So this is, a 1.5 second, sound sample, and you could see how the frequency and the intensity changed with time, right? But kind of on here, you could see, this is a 3D plot. I thought it was kind of neat where, we're saying 1, 2, 3, 4, 5, 6, 7. So I think we're saying words like sit, nip, stuff like that. And you could see that, we were doing a frequency analysis and the different, so as the different sounds you could see on the time, 1, 2, 3, 4, 5, 6, 7 different, consonants we said here, you could see the different frequencies of each one. And you kind of think about, oh, what can I do with these? What am I going to do with this when I get out of school? But, this is kind of very similar things that we did in telecommunications as well, right? You actually have to look at things like this, which is a Fourier transform of the different, or this one's a time-based FFT, but you look at the different frequencies of the components in your signals and you analyze them based on the frequency and intensities that you're getting, right? So, that's how things might be related in here. So this is an example of a lab that you might do in DSP, is how to sample, how do you actually get clean samples, how to analyze them, and also if that's kind of things you're interested in, will be signals. Y'all have any other questions?
I have a quick one.
Okay.
What got you interested in this concentration? Like, was it a class or I know you said you had previous experience with microcontrollers.
Right. It sounded fun.
All right.
That's what got me interested in it. Like I said, do something that you enjoy because that's what you're going to be doing. You want to enjoy what you do. You don't want to be going to work every morning and say, "Oh, I really hate what I'm doing," because then you're going to be miserable. I'm sure nobody likes doing that. So if this is what you're passionate about, do it. If you think you're interested in it, do it. And don't get me wrong, I mean, it's fun, but it's also going to school here has been the hardest thing I've done in my life. It's mentally taxing, and it's definitely one of the most challenging things I've ever done. So, I mean, it's definitely not easy, but I guess that's kind of what keeps you going, is that, okay, I am interested in it and I like what I'm doing. So even though it's tough, I can keep going because, I'm learning